Hey everyone, today we'll be talking about graphing numerical functions on a coordinate plane. Now, graphing essentially creates a picture of a function. Its goal is to create a visual aid that helps viewers, including yourself, see the big picture behavior of how the function works. In fact, it's useful enough that any sort of presentation out in the world that presents the information in a function and wants to talk about a function will include a graph along with it as an aid. Below I've got two examples, one from a physics paper and one from an article on the 2014 Ebola outbreak. And in both cases, we're going to take a quick look at how the picture helps illustrate the large-scale behavior of the function. For example, in the first one, the physics paper, we've got a picture that illustrates the relationship between the input variable, this time-related variable, the output variable, energy. It has several curves modeling the progression of energy as time passes. And you can see that this black curve here does a wonderful job of illustrating the trend described in the paper, where it says, we see from figure 1, this figure, that energy initially decays, that goes down, but then increases with time, like so. Another example is this graph that I lifted from an article about the 2014 Ebola outbreak. You can see that the input here is the date, and the output is the number of cases on that date. Looking at the graph, you see that cases shot up quite quickly at an increasing rate, just as the paper described, right? This paper says, this plot makes a point about the nature of exponential growth that is illustrated by this picture. So the way a graph works is that for each point along your graph, the location along the horizontal axis represents your input, whereas the location along the vertical axis at that horizontal point represents your output. And this will be written in ordered pair form, like so, where input and output are together in this set of parentheses. I'm going to illustrate that with this function right here that I've drawn, f from the numbers to the numbers. Here we're going to label our axes. We'll just call them input and output. And we see that 1 maps to 2. So we'll do some scaling. 1, 2, 3. The scaling on the vertical axis will be a little bit bigger, so we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. And we can graph 1 mapped to 2. So we go to a horizontal distance of 1. We match that up to the output of 2 and have 1 point on our function be right here. This point will be written as 1, 2 to represent the function with an input of 1. And we can continue on doing that. When we input 2, will be here on the horizontal axis, and we go up to 5 on the output axis, which puts us right here at the point 2, 5. When we input 3, we start it here on the horizontal axis. We go up to 10. So right here. So that's 3 points on this function. Our third point, 3, 10. And if we were to continue on and try to draw a trend, we would get some curve that looks probably something like this. Alright, let's do another example. Here we've got g from the numbers to the numbers, whose mapping is defined by g of k equals 200k plus 100. So let's start by labeling our axes. We've got input here, output here, and let's look at 1 here, 2, 3, and -1, -2, -3. And since our scaling is fairly large, we'll do 100, 200, 300, 400. So intervals of 100. Likewise, here we're going to have -100, 0 here, should clarify, -200, -300, and so on. Okay, let's start out by plotting g of 0. So we have g of 0 equals to 200 times 0 plus 100 equals 100. That corresponds to horizontal point of 0 and a vertical height of 100. So our first point is going to be here, and we're going to label it 0, 100. Let's also graph k equals 1. So we'll have g of 1 equals 200 times 1 plus 100, which is equal to 300. So at 1, we're going to go up to here, at the point 1, 300. Likewise, we can continue on to k equals 2. We have g of 2 equals to 200 times 2 plus 100, which equals to 500. Here I'm going to extend my axes a little bit, 500 here. So we go up from 2 until we hit the height of 500. And graph 2, 500. And finally, let's do one more point. We'll do k equals -1, so -1. And that equals to 200 times -1 plus 100, which equals to -100. So we're going to go to -1 until we hit the height of -100. Plot the point right here at -1, -100. Now, if you've come into contact with linear functions before, you know just by looking at the function rule itself that this function should look like a line. So when we graph it, that is indeed what we get, a very linear relationship between k and g of k.